Morning students, as this welcomes you all. In the last lecture we have discussed about the relation between drift velocity and current, mobility and all. Now we are going to discuss the most important, the very interesting topic, that is Ohm's law here. What is Ohm's law? We know that what is Ohm's law? What it is stated that it states that if the physical condition remain unchanged, if the physical condition like temperature, pressure, etc. remain unchanged, then the current flowing in a circuit, is always directly proportional to the potential difference across that circuit. What I said? I said that according to this law, if physical condition, if physical condition if physical condition like temperature, pressure, etc. remain unchanged, then the current flowing in a circuit, flowing in a circuit is directly proportional to the potential difference across that circuit. What I have written here, that is, if the physical condition like temperature, pressure, remember this point that temperature, pressure should be unchanged, that means should be constant. If the physical condition like temperature, pressure remain unchanged, then the current flowing in a circuit, that is I, is directly proportional to V. And this can be written like V is directly proportional to I, so that it can be written like V is equal to IR. Some of you can put the question that I is directly proportional to V. Why we have not written here I is equal to VR? Why we have not written this point? As we know that resistance is what? Resistance is an obstacle put in the path of the flow of the current. So with the increase in resistance, current cannot be increased, and here it is showing that directly proportional symbol with the current, that I is directly proportional to R. From this relation, if we are writing like this, so this is impossible, because when the current is increasing in a circuit, resistance cannot be increased, and when it is decreasing, then only that current can be increased. That means it should be in inversely proportional symbol. So here from this equation we can find out that I is inversely proportional to R, and this particular relation is current, and this one is current. That is why I is written like I is directly proportional to V, and then we are writing V is directly proportional to I, that is V is equal to IR. But we are not writing that I is equal to VR, because from this relation I is directly proportional to R, and that is impossible. So this should be clear to you. When the resistance is increasing of a circuit, then the current cannot increase, and that both are not directly proportional to one another. They are inversely proportional to each other. So here this one is your Ohm's law. What it is? It is that if physical condition like temperature, pressure remain unchanged, then the current flowing in the circuit is always directly proportional to the potential difference across that circuit. Moving further, if V is directly proportional to I, then there should be a relation. For this relation, Sir George Simon Ohm has given one of the relation for two of the conductors. One is said to be ohmic, and another one is said to be non-ohmic. What are the ohmic conductors? What are the non-ohmic conductors? The conductor which obeys Ohm's law, the conductor which follows Ohm's law or obeys Ohm's law, that are known as ohmic conductor, and the conductor which do not obey Ohm's law, that is called non-ohmic conductor. The conductor which obeys Ohm's law, for them I is directly proportional to V, or we can say that V is directly proportional to I. But for this non-ohmic conductor, they will not follow this. So for the ohmic conductor, if we are just going to discuss the VI characteristic of this, then what is the potential difference, the current characteristic of this. Let us discuss here. For the VI characteristic of ohmic conductor, for the ohmic conductor, because they obey the Ohm's law, that is V and I. The relation of V and I would be a straight line. Would be a straight line. And for non-ohmic, conductor, for non-ohmic conductor, it is what? It can be curved or it can be irregular. It can be curved or it can be irregular. That can move any of the state. So here, what we have discussed Ohm's law. What is Ohm's law? Repeat it again. What is that? If the physical condition like temperature, pressure, etc. remain unchanged, then the current flowing in a circuit is always directly proportional to the potential difference across that circuit. And why we are not writing I is equal to VR, I have discussed you. And this one is about VI characteristic of ohmic and non-ohmic conductor. Here the terms come, that is R. What is R? R is called resistance. R is called resistance. Let me discuss with you what is resistance. The hindrance offered by the circuit or the wire in the path of the flow of the current, that is called resistance. Let us take this topic and discuss briefly what is resistance. Here we are going to discuss about resistance. The hindrance offered by or obstacle, the hindrance and obstacle offered in the path of the flow of the current, in the path of the flow of the current. Flow of the current. So the hindrance which is offered in the path of the flow of the current, that is said to be resistance. It can be due to circuit, it can be due to wire. It is indicated like this symbol. This one is R, this one is resistance, and if you are attaching this circuit like this, the current is flowing in this direction, and this one is R. R is indicating here resistance. So it is indicated by capital R, and its unit is on the basis of Sir Simon Ohm. It is written like what? Ohm. It is written like its unit is Ohm. Now, moving further, what is the relation of this in series and parallel combination? For this, we are going to study the series and parallel combination of the resistors. Combination of resistor. First of all, we are just going to talk about series combination. What is series combination? If two or more resistors, concentrate over here, you'll be getting that. If two or more resistors are attached between 2 points, like the first end of first resistor is attached to the first point, and the second end of first resistor is attached to the first end of second resistor, and the second end of second resistor is attached to the first end of third resistor. Likewise, many of the resistors are attached between 2 points, like the last end of last resistor. The last end of last resistor is attached to the second point. Then this type of combination is said to be what? Series combination. What I said? I said if you are just keeping your hand, like your one hand is attached to the first point and your second hand is attached with the first hand of second person. Likewise, many of the persons are attached. Then this type of combination is said to be what? Combination in series. Here we are going to talk about only 3 of the resistors we are taking between 2 points. this one is R1, R2 and R3. These three resistors are attached between 2 points. This one is A point, this one is B point. We are taking likewise. The current flowing in series, that would be same. Remember this, in series I would be same. I same, V change. So for R1 it is V1, for R2 it is V2, and for R3 we are taking it V3. By Ohm's law, we have what we have by Ohm's law, that V is equal to IR. This one is the question number 1. For first resistor, similarly, for first resistor, V1 can be written like what? I R1, because I have told you in series I same V change. So V1 is equal to I R1. This one is question number 2. For second resistor, V2 can be written like I R2. This one is question number 3. For the third resistor, look at here everyone. For the third resistor, V3 can be given like I R3. But from where they are getting the voltages? They are getting the voltages from a battery, that is V. So net voltage, net potential difference is V is equal to V1 plus V2 plus V3, equation number 5. If we see from equation 1 to 5, we can put all the values here. What is that? Look at here. That V is equal to, what we are getting, that V is equal to V1 plus V2 plus V3. So that V is written like IR. This one can be written like IR1, and this one can be written like IR2 plus IR3. Here, I can be taken as common. This one is R1, this one is R2, and this one is R3. So I can cancel each other. Then R is equal to what? R1 plus R2 plus R3. This one is the net resistance of the series combination. We are getting that this one is what? R is equal to R1 plus R2 plus R3. What about the parallel combination? If we are talking about the parallel combination, how will you find that? What is parallel combination? Let us talk about that parallel combination. Parallel combination of resistor. What is parallel combination of resistor? Let me tell you what is parallel combination first of all. What is parallel combination? In this combination, all the end of all the resistor, all the first end of all the resistors is attached to the first point, and all the second end of all the resistor is attached to the second point. Then this type of combination is said to be parallel combination. Likewise, in between 2 points, I am attaching 3 of the resistors. Let's say R1, R2 and R3 between point A and B. Like we can see here, all the first end of all the resistors attached to the first point, and all the second end of all the resistors attached to the second point. Then this type of combination is said to be what? Parallel combination. Let this attach to the battery. Always remember one thing, as in series combination, I remains same and voltage changes. Here V remains same and I changes. So here V same, I change. Remember this always. So the current I is flowing through it. Up to this, it is only one path, and here it is getting 3 of the paths. So here I1 would go, here I2 would go, and here I3 would go. Again, here I would go, and here the voltage would be used V1, not V1, V2. Remember, V same. So V, and this one would be. This is also V. So for this, we can write by Ohm's law. V is equal to IR. From here we can find out that I is equal to V upon R. Equation number 1. For first resistor, what will you write? That V is equal to I1 R1. This can be written like what? R1 is equal to V upon R. Equation number 2. For second resistor, what will you write? For second resistor, if we are talking about second resistor, we are writing it here I2 R2, and this can be written like I2 is equal to V upon R2. This one can be equation number 3. Similarly, for third resistor, what we are getting here? For third resistor, V is equal to I3 R3, and this can be written like what? I3 is equal to V upon R3. Equation number 4. From equation 1, 2, 3 and 4, we can just find out that I is being distributed in I1, I2 and I3. So, net current, I can be written like what? I1 plus I2 plus I3. Is it so? From equation 1, 2, 3 and 4, we are just putting the values. That is V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. V can be taken as common. This one can be written like 1 upon R1 plus 1 upon R2 plus 1 upon R3. V cancelled out. That is 1 upon R is equal to 1 upon R is equal to what? 1 upon R1 plus 1 upon R2 plus 1 upon R3. This one is your result. That in parallel combination it is written like 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this one is all about series and parallel combination of resistor. I hope you all are getting all these points. Similarly, we'll talk about the next topics in the next lecture. And here, if anyone is having any confusion, they can give their doubts regarding these all topics. Thank you, as this will see you again in next lecture.